In this video, we're going to be introducing the topic of sequences and looking at a specific type of sequence called an arithmetic sequence. Now, a sequence is just an ordered list, in other words, a pattern. To illustrate, here are some examples of sequences. In the first one, we see that to get to each successive number, we're just adding 4 each time. In the second one, we see that to get to each successive number, we're multiplying by 2. The third one is a more complicated sequence known as the Fibonacci sequence. Once we get the first two ones, to get the 2, we add 1 and 1 together to get 2. Then 1 and 2 gives you 3, 2 and 3 gives you 5, 3 and 5 gives you 8, etc. The next number would be 5 plus 8 is 13. And the last one is just the alphabet, of course. Arithmetic sequences are ones of this type, where to get from 3 to 7, we add 4. 7 to 11, we add 4. And 11 to 15, we add 4. We're adding the same amount each time. In the second one, to get from 5 to 2, we're subtracting 3. Then from 2 to negative 1, again, we're subtracting 3. And then from negative 1 to negative 4, we're subtracting 3. These are a special type of sequence called an arithmetic sequence. So an arithmetic sequence is a sequence in which we add the same quantity, and we're going to call that the common difference, d, to get each successive term. If we go back to those examples then, here the common difference, d, is 4. We're adding 4 each time. Here the common difference is negative 3. And don't get confused by the fact that we said in the definition we're adding the same amount. We can just think of this as adding a negative number. If we go back to the original examples then, you can see that the first one was an arithmetic sequence. We were adding 4 each time. The others are sequences, but they're not arithmetic sequences. There's some notation you need to be comfortable with when working with arithmetic sequences. We've already said that the common difference is the amount that you add each time to get the next number, and that that's abbreviated d. We need some notation for signifying the terms in the sequence. So if we number all the terms from 1 to however many terms we have in the sequence, the 9th term, for example, we would abbreviate like this, t for term with a little sub 9. If we go back to the original example then, this would be T1, 7 would be T2, 11 would be T3, 15 would be T4, etc. The nth term then, where n is standing in for a number, would just be T sub n, and n can take on any value. The first term, of course, would be T sub 1. A little bit confusingly, sometimes you'll see the letter A used to represent the first term, and we'll use that later when we develop a formula for terms in an arithmetic sequence. Now let's do a problem. Find the 21st term in this arithmetic sequence. Using the notation that we just worked out, we know that A, or term 1, is equal to negative 1, and the common difference here, to get from one to the next, we're always adding 6. We're adding 6 here, we're adding 6 here, and so because it says it's an arithmetic sequence, that's the way it's going to continue. Now notice that this is term 1, this is term 2, this is term 3. To get from term 1 to term 2, we added 1 6. To get from term 1 to term 3, we added a total of 2 6s. We're adding the 6s in the spaces, so to get from term 1 to term 3, we added 1 less 6 than the total number of terms. Here there's 3 terms, but there's 2 6s that we've added. You can imagine then to get to the 10th term, we'd have to add 6s in the spaces, and that would be 9 6s that we'd have to add. So to get to the 21st term, we'd have to add 20 6s in the spaces, 1 less 6 than the number of the term we want to get to. So term 21 is going to be equal to that negative 1, plus we have to add a certain number of 6s. How many? We just worked out to put them in the spaces. We're going to need 20 of them, 1 less than 21. 20 6s gives us a value of 20 times 6. Then we add the first number, which is negative 1. So the 21st term is equal to negative 1 plus 120, which is equal to 119. If you had trouble with that, pause the video, go back and watch through that again. The idea is that we're adding 6s, the common difference in the space, so we need to add 1 less than the number of the term we want to get to. We'll develop a formula in a moment that'll help us do that, but this is helpful for getting an appreciation of what's actually happening. A bit more terminology. The general term is simply a formula that tells you how to find the value of each term if you know its position. This is an expression of a general term. So when a question asks you for a general term, it's asking for something like this. This is saying t sub n, so any term in the sequence, is equal to 4 times n, 4 times the number of the term in the sequence, minus 1. So that's going to generate this list when we sub in the different values of n. Let me illustrate. This is term 1, this is term 2, this is term 3, this is term 4. If we look at n, the number of the term in the sequence, n is, for this one is 1, for this one is 2, for this one is 3, for this one is 4. If I sub in 1 into this formula, so 4 times 1 is 4 minus 1, that gives me 3. If I sub 2 into the formula, 4 times 2 is 8 minus 1, that gives me 7. If I sub 3 in, 4 times 3 is 12 minus 1 gives me 11. So subbing in the number of the term, its position in the sequence here for n, and then evaluating the formula gives me the actual value of the term in the sequence. So this is called a general term. Now, for an arithmetic sequence with first term a and common difference d, we can work out the general term using an approach that we just did in the last problem. To get any term, we're going to have to start with the first term, which is a, and then we're going to have to add differences in the spaces. We're going to have to add a certain number of differences. In the last example, the value of the difference was a 6, so this was a 6. And we saw that to get to the 21st term, we had to add 26s. So to get to the nth term, we're going to have to add n minus 1 differences. That parallels what happened here. The first term was a, we had to add some number of differences, some number of 6s, and it turned out that because we were adding them in the spaces, we had to add 1 less than the number of the term we wanted to get to. Here we've just made that general. To get to the nth term, we start with the first term. In the problem it was minus 1. Then we add some number of differences. Previously this was 6 and this was 20. So that's a formula now for any term in an arithmetic sequence. If you know the first term, you know the common difference, and you know what number it is in the sequence, you can work out what the value is. Also, given any 3 of these, you can work out the 4th. Here's an example. Find the general term and the 15th term of this arithmetic sequence. The first thing to do when given a problem like this is write down what you know. So you know that the first term is 3, and you can work out just by looking at it that the common difference d is 4. To get the general term then, we're going to write our formula. The nth term is equal to the first term plus n minus 1 differences. And now we're going to plug in what we've got. Term n is equal to 3 plus n minus 1, and we're going to leave all the n's general, times the difference, which is 4. Now, this is the general term, but it's good practice to simplify this and collect like terms. So we're going to write the nth term is equal to 3 plus, distributing here we get 4n minus 4, and then collecting like terms, we get that the nth term is equal to 4n minus 1. And you'll notice that that's the same general term that we just saw back here, and it's the same sequence. So we actually knew the answer, but that was showing us where it comes from. Now we found the general term, and it's asking us to find the 15th term. We can just sub 15 in for this n, because we want the 15th term. Because we've subbed 15 in for n on the left side, we have to sub it in on the right side as well. So we get 4 times 15 minus 1. That's equal to 60 minus 1, which is 59. So the 15th term is 59. Here's another example. Find the number of terms in this arithmetic sequence. So again, the first term, a, is 27, and the difference in this case is negative. It's going to be negative 8. We don't know, in this case, what n is. We don't know how many terms there are in this sequence. But we do know that the last term, and we'll call that term n, is negative 365. So now we're given 3 values and we want to find the 4th, and again we're going to plug them into this formula. So negative 365 is equal to 27 plus n minus 1, d is negative 8. Be careful of your brackets so that the negative is inside there. If we move the 27 over, subtract it off both sides, we get negative 392 is equal to n minus 1 times negative 8. Let's divide both sides by negative 8. That gives us, on a calculator if you need it, 49 is equal to n minus 1, and then adding 1 to both sides, we get 50 is equal to n. That means that there are 50 terms in this sequence. Here's another type of question that gets asked commonly with arithmetic sequences. Find k given that 3k plus 1, k, and negative 3 are consecutive terms of an arithmetic sequence. So consecutive terms means there's no terms in between them. So you get 3k plus 1, the very next term is k, and then the next term after that is negative 3. Now we know that if they're consecutive terms, then to get from 3k plus 1 to k, we have to add some common difference, d, and then to get from k to negative 3, we have to add some common difference, d. Now how do we figure out what that difference is? Well, let's think of an analogous situation. In the arithmetic sequence 1, 4, 7, we know the common difference is 3. How do we get that? Well, we can take 4 minus 1 to get 3, or we can take 7 minus 4 to get 3. So we do the same thing here. To get this common difference, we take k and we subtract 3k plus 1, and that has to equal d. If we're careful of our brackets and our negative signs, we get k minus 3k minus 1 is equal to d. So negative 2k minus 1 is equal to d. Over here, similarly, just like 7 minus 4 is 3, we do negative 3 minus k, and that's equal to d. Now, because negative 2k minus 1 and negative 3 minus k are both equal to d, we can set them equal to each other. Negative 2k minus 1 has to be equal to negative 3 minus k, because they're both equal to d, therefore they must be equal to each other. Now if we simplify this, move everything to opposite sides, we bring the negative 2k over here, and we get k on this side, and we bring the negative 3, add positive 3 to both sides, and we get 2. So k is equal to 2. If we plug that back in here, 3 times 2 plus 1 is equal to 7. This would be 2, this would be negative 3, and we can see that to get from one to the next, we're subtracting 5. The common difference is negative 5. So that's an approach to solving this kind of question. And that's an introduction to sequences and to arithmetic sequences in particular.